about a very important topic in operations management, that is the project management. And let's have a brief review, students, what we did in our previous lecture. Students, in the last lecture we discussed a very important topic in project management, that is PERT CPM, and you must know that we discussed some of very important tools which may be very helpful in managing the different projects. And one of the tool in project management is PERT CPM, that is Program Evaluation Review Technique and Critical Path Method. And we discussed the framework of PERT and CPM technique, and we also discussed that what is the importance of this networking technique. This technique actually helps us to draw the diagram or a network which shows the interrelationships between the different activities of the project. And after drawing this network diagram, we are able to find out the critical path for our project, and that critical path helps us to identify that what are the critical activities in our project. And these critical activities are the most important activities of the project, and we cannot delay any of these critical activities. And I also told you that how we compute the critical path, and I told you about the earliest event time and latest event time, and finally we find a path in that network diagram at which the earliest event time and latest event time are equal for all the events. So that particular path is usually referred as a critical path, and that critical path actually tells us about the total duration of the completion of the project. And we cannot complete a particular project before that particular time, and it is actually the shortest possible period in which we can complete our projects. So we discussed, students, in detail about this PERT and CPM. Then I also told you that how we can calculate the expected time for the different activities of a project. We can always take into account three important factors when we are going to calculate the expected time for the different activities. That is the most pessimistic time, most probable time, or the optimistic time. And optimistic time is the time that in which your project may be completed when there is an ideal situation in future. And the most probable time is the time when most of the factors about your project remain normal in future, and you guess that the most of the conditions for your project will remain normal in future. And the pessimistic time is the time taken for the completion of the project when there are abnormal conditions in future. So what the project managers do, they can estimate all of these times, and then they can use the weighted average to calculate the expected time period for the different activities of the project. Students, we also discussed some important tools that like Gantt chart and work breakdown structures and linear responsibility charts. Gantt chart is a sort of chart in which we can indicate the different activities, and we can compare that from what time period a particular activity will start and what time the particular activity will end. So this is the Gantt chart. And work breakdown structure also can be represented. And work breakdown structure helps us to break down the different tasks into the subtasks and further levels of tasks, so that we can accordingly contribute and allocate the different resources in order to complete the overall activity and task. Linear responsibility chart is another important chart the project managers can use while managing the different projects. And this is a sort of chart which actually shows the different responsibilities of the different persons, that which person will report to what person, and what job may be assigned to which person. And again, we can use the different legends in order to show the responsibilities of the different human resources. So this is a very important concept again in order to represent the different responsibilities in the form of a particular chart, which may be termed as linear responsibility charts. So students, these were very important topics we discussed in our previous lecture. In our 2 days lecture, again we will discuss some important concepts of project management, and especially we will discuss that how we can do the financial analysis of the projects. And again students, when we define the projects, we also define that the projects are the sort of investment activities which should be economically viable, socially desirable, and most importantly financially it should be profitable. So the financial analysis of the projects is so important that it will help us that whether we should take up the project or not. And again we also discussed about the different alternatives and about the different techniques, that how we can select a particular project if we have many projects. And this financial analysis helps us to select a particular project in that particular sense, that which is the most profitable project for a particular organization. So this financial analysis in that particular aspect is the most important technique in the project management. In this financial analysis, we will discuss some important concepts like time value of money. And again, you must have know about this time value of money. That is the value of money now is always greater than the value of money you will get in the future. So the present value of money is always greater than the same amount of money you may get in future. So that is the concept of time value of money, and of course we will discuss this particular concept. Payback period again is a very important financial aspect which can help us that in what period we can cover up the capital investment of our project. And again this is a very important indicator which may help you that whether we should take up with the project or not. Then students, a very important concept again in project management and especially in the financial analysis is the net present value. And net present value is actually defined as the difference between the aggregated discounted benefits and the aggregate discounted cost. And we will discuss that what is discounting and what is compounding, and how we will be able to calculate the net present value. Similarly, the benefit cost ratio, as its name shows, that it is the ratio between the aggregated benefits and aggregated cost of the project. Again students, these concepts NPV and BCR are so important concepts that they may indicate that whether we should take up with the project or not. And we will discuss the benchmarks and the different values and their interpretations. Then another important concept in financial analysis of the projects is the internal rate of return. Again students, we will discuss that how we can calculate the internal rate of return, and that is actually the discount rate or the rate of return at which the net present value becomes 0, or we can say when the BCR becomes equal to 1. So again I will discuss with you that how we can calculate all of these particular concepts for the different projects, so that we may have the idea that which project should be selected or which project should be preferred over the other projects. So important is the financial analysis of the projects. Time value of money. Conceptually, time value of money means that the value of sum of money received today is more than its value received after some time. Conversely, the sum of money received in future is less valuable than it is today. So students, the money we now have in our hands is always have the greater value than the same amount of money we may get in the future. So that is the concept behind time value of money. In other words, the present worth of a rupee received after some time will be less than a rupee received today. So our rupees you may get in future will always be having the less value than the same rupee you may get today. Since a rupee received today has more value, individuals as rational human beings would naturally prefer current receipt to future receipts. So that's why most of the financial analysts and the operation managers and the finance managers, they always prefer the money they can get today rather than having the money in the future. Now again, the concept is same, that the present value of money is always greater than the future value. So this is the concept behind time value of money, students. In order to have the logical and meaningful comparisons between cash flows that result in different time periods, it is necessary to convert the sums of money to a common point in time. So students, we may have the different cash flows when we are going to conduct a particular project, and you may get some of the money today, and you may get some of the money after 1 year, after 2 years, or after 5 years. So in order to have the fair comparison or the financial comparison of the cash flows, what we'll have to do, we'll have to get the amount of money or the value of money at a single time period. That is, either we can calculate the value of money today for all of the different cash flows, or we can get the value of money for the some future time period. So we should have some common time period, that is that may be today or that may be tomorrow. So students, it is necessary to have a common point in time in which we can calculate the value of money that may be calculated at the present time period, or that may be calculated at some future time period. So after having the value of money at some common time period, it will be always better to have the financial analysis of the different cash flows. In that particular perspective, we use the two different types of techniques, and these techniques are generally referred as compounding and discounting. Now again students, we have the two different formulas, that is the present value formula and the future value formula. You can see that future value formula is future value is equal to P, that is the present value, into 1 plus I raised to power n, where P is the present value of money, I is the interest rate, and n is the number of years, and f is the future value of money. And in order to calculate the future value of money, we use the general term, that is compounding. Similarly, the formula for present value of money is P is equal to f over 1 plus I raised to power n. Again, P is the present value of money, f is the future value of money, and I is the interest rate, n is the total number of years. And again, whenever we calculate the present value of money, we use the term discounting for this particular purpose. So in order to have the financial analysis of the projects, we'll have to calculate the present value of the different cash flows, or the future value of the different cash flows, by using either of these formulas. Compounding technique. Interest is compounded when the amount earned on an initial deposit, that is the initial principal, becomes part of the principal at the end of the first compounding period. The term principal refers to the amount of money on which the interest is received. So students, whenever you have some initial deposit, that deposit is said to be as initial principal amount, and after a particular time period, you may get the interest on that principal amount, and this interest is actually compounded when the amount earned on an initial deposit, and at the end of the different time period, this interest again is being added on the principal amount. So the term principal refers to the amount of money on which the interest is received. Again, students, I have told you about the time value of money, that an amount of dollar invested now will be worth more when the principal and its accumulated interest are received n years from now. Or money can earn interest during the time it is invested. A future return is worth less at the present time. So again students, as I have told you, that the present worth of money is always greater than the worth of money in future. So again, this is the formula for calculating the future value of some investment. F is equal to P into 1 plus I raised to power n, where F is the future value of the investment, P is the principal amount, or P is the present value of the investment, I is the annual interest rate, and n is the number of years for which you are making that particular investment. Let's students discuss some important examples, that how we can calculate again the future value or the present value of some of the investment in the different projects. Let's take this particular example. Suppose you have an initial investment equal to $1,000 in a project, and the interest rate is equal to 10% a year. and it is compounded annually. Now this point is very important, that we'll have to see that whether the interest is compounded annually, or it is semi-annually, or it is quarterly, or it is monthly. So accordingly we'll have to change the formula according to the compounding interest. So suppose the time period is 1 year and you have invested this $1,000 for the 1 year. Now this $1,000 is actually the present value of your investment, and if we put this information into this formula, that is F is equal to P into 1 plus I raised to power n. So in this case P is 1000 and I is equal to 10%, so it will become 0.1, and n is the number of years. In this particular case the number of year is 1, so n will be equal to 1. So if we put this information in this formula, we will get the future value of money $1,100. So students, according to the given information, the present value of money, that is $1,000, that will be equal to $1,100 in future, that is after 1 year. So in this way, by using this particular formula, we may be able to calculate the future value of money. Now let's suppose that the investment is made for 2 years. Now what we will do, again we will use the same formula, that is F is equal to P 1 plus I raised to power n. This will be again equal to $1,000, which is the principal amount or the present value of the money. Now 1 plus 0.1, 0.1 means 10% interest rate, so it will become 1.1, and the power is 2, because now the number of years are 2. So again, if we solve this particular equation, the value of the future money will become $1,210. We can also calculate the 2 years compound interest by investing first year's principal and interest. So as you know that after 1 year we got this future value as $1,100, so we can alternatively calculate the future value after 2 years by using this particular formula, that is F is equal to P 1 plus I raised to power n. So now P is the value we get after 1 year, that is 1100. So 1100 multiplied by 1.1 raised to power 1, it will be equal to $1,210. So you can use either of these ways to calculate the future value of money after 2 years. So students, in this particular example we just have discussed, we discussed that the interest is compounded annually, that is the interest will be applied on the principal amount after 1 year. So that time period may change with respect to the particular investment. Now let's consider the case if the compounding is done quarterly. Now what happens? Quarterly means that after every 4 months quarterly means the interest will be applied 4 times in a year, that is after 3 months the interest will be applied. So it means the interest will be applied after every 3 months. So in a year the interest will be applied on that principal amount 4 times in a year. So it means that compounding is done quarterly, that is the 4 times. So what will be the change in the formula? Suppose again consider this particular example, that your investment is $1,000, the interest rate is 10% a year. Now again students, this is the interest rate 10% a year, compounding quarterly. So if you are interested in compounding quarterly and the total time is 2 years, now what will be the change in this formula? Now formula will be F is equal to P into 1 plus I over 4 raised to the power 4 multiplied by 2. Now students, what we do in this particular formula, we have divided that interest rate by 4. Now why we have divided by 4? Because the compounding is done quarterly. As I say that 4 times the interest will be applied on a particular amount. So that's why what we will do, we will divide that interest rate by 4, and in raised to power what we will do, we will multiply this 4 by the total number of years, so the total value in this particular case will become 8. So the formula will be like this now: 1000 multiplied by 1.025 raised to the power 8 is equal to $1218.4. So students, what we have done in this particular example, because the compounding is done quarterly, we divided the interest rate by 4, and again the number of years are being multiplied by 4. So by making this particular change, we can again get the future value of money when the compounding is done quarterly. Now let's again take the example that compounding is done monthly. Again, monthly means students, you'll have to apply the interest on the amount 12 times a year. So again, if the now again, if we consider the same example, that is the investment is equal to $1,000, your interest rate is again 10% a year, and the compounding is done monthly, and we are interested to calculate the future value of money after 2 years. Now again, what will be the formula? That is, future value is equal to present value multiplied by 1 plus I divided by 12. Now students, again, because we are compounding monthly, therefore we will divide this interest rate by 12. Previously the compounding was quarterly, so that's why we divide the interest rate by 4. But in this monthly compounding case, we will divide the interest rate by 12, and again the number of years, that is n, will be multiplied by 12. So by making these particular changes in this formula, we can get the future value of money when the compounding is done monthly. So this is the way the compounding can affect the future value of money. So again students, if we are doing the compounding daily, then and we suppose that there are 360 days in a year, and again we will have to apply the similar sort of changes. That is, we'll have to divide the interest rate by 360, assuming that there are 360 days in a year, and again n or number of years will be multiplied by 360, and again by these particular changes we can get the future value of money equal to $1,221.5 if the compounding is done daily. So students, we discussed some different examples that how we can calculate the future value of money by applying that particular formula, that is F is equal to P into 1 plus I raised to the power n, and how we can change the interest rate and the number of time periods if the compounding is done monthly or quarterly or semi-annually. Again, if we are doing the compounding semi-annually, what we will do in this particular formula, we will divide this interest rate by 2, and n will be multiplied by 2. So these are the different changes you should take into account when the compounding is done at the different time periods. So again students, I told you that whenever we are interested in finding out the present value of some future money, then in that particular case we use the term discounting, and if the future value of an investment is known, we can easily derive its present value given an interest rate and the number of compounding periods. So again students, in order to find out the present value of the money, we will use this particular formula, that is P is equal to F divided by 1 plus I raised to the power n, where P is the present value of money, F is the future value of money, I is the interest rate, and n is the total number of years for a particular investment. Now students, let's take the example of that how we can calculate the present value of some future money. How much money to invest now at 10% compounded annually to receive $1,000 in 5 years. Now students, we want to calculate the value of money now. It means that we want to calculate the present value of money. Interest rate in this particular case is 10%, and future amount of money is $1,000 now, because it is the amount we will get after 5 years. So students, again we will use the same formula. P is equal to $1,000, that is the future value of money, divided by 1 plus 0.1, it will become 1.1 raised to the power 5. So if we calculate this value, it will be $620.7. So it means that $1,000 you may get after 5 years will have the value of $620.7 now, if that discounting is done annually. So in this way, students, by using this particular formula, we can calculate the present value of money. Again, students, let's discuss an example that how much money to invest now at 10% compounded quarterly to receive 1,000 in 5 years. Now, how this question is different from the previous one, because now the compounding is done quarterly. So again, the students, as I already told you, that we'll have to do some changes in that particular formula. What we will do, we will divide the interest rate by 4, because the compounding is done quarterly, and again the number of time periods, that is n or 5 in this particular case, that will be multiplied by 4. So the formula will become P is equal to 1000 divided by 1 plus I divided by 4, and raised to the power n multiply 5 multiplied by 4, it will become 20. So if we divide the interest rate, that is 10% by 4, and if we add this value to 1, it will become 1.025, and if we solve this particular value, it will become $610.3. So this is the amount or the present value of money if the compounding is done quarterly. Now students, what we were doing in this particular case, we were calculating the present value of money for the different investments after the particular time periods, and let's discuss the concept of net present value. What is net present value? The net present value method requires that all the cash flows be discounted to their present value using the firm's required rate of return, and this is the formula for the net present value. Now students, what is the concept of net present value? Net present value is actually the difference between the aggregated discounted benefits and the aggregated discounted cost. Now what happens when we have the different cash flows that may be in the form of profits or that may be in the form of cost or investment? What we do, we calculate the present value of our cash flows for the different time periods, and then we will add up all of these cash flows, and that sum will be termed as net present value. So that's why we say that it is the difference between the aggregated discounted benefits, that is the aggregated discounted value of all the cash inflows, that is the profit, and aggregated discounted cost, and that is the discounted value of all the investment or the cost. So the difference of these aggregated discounted benefits and aggregated discounted cost will be equal to the net present value, and this is the formula for this net present value. You can see that summation AT over 1 plus I raised to the power t. Now in this particular case, students, this A is actually the present value of money, and I is representing the interest rate, T is the time period, C is representing the cost. So what we will do, we will calculate the aggregated discounted benefits and aggregated discounted cost. We will have the difference of these two values, and that particular value is the net present value actually. So net present value takes into account the time value of money, and regardless of the pattern of cash flows, a single net present value is calculated. So in order to calculate the net present value, what we will have to do, we'll have to discount all the different cash flows, and then by adding these different discounted cash flows, we can get the value of net present value. Now students, as I told you that these concepts like net present value, benefit cost ratio, payback period, IRR, that is the internal rate of return, these concepts are so important for the selection of the different projects, and these the concepts will give you the idea that whether we should select a project or not, or which project should be selected among the different alternative projects available for the organization. So let's discuss this particular case. Suppose students, we have two projects, that is the project A and project B. Now these are the time periods, that is 0, 1, 2 and 3. Now you can see that the cash flows for these two different projects, that is project A and project B, are given in this particular table. Now you can see that at present you'll have to have the investment of $2,500 in the project A. Now we have represented this value as a minus sign. Now why we are using minus sign here? Because this 2,500 is your cash outflow, that is your investment or the cost of that particular project. So that cost is actually represented by a negative sign here. In the first period, or after 1 year, the project A will be able to generate the revenue of $1,000. After the 2 years, project A will be able to generate the revenue of $1,500. And at the end of third year, the project A will be able to generate the revenue of $1,000. So this is what is meant by all of these values for the project A. Similarly, the project B has the initial investment of $2,500, as was the case for the project A. And again, we have represented this particular value by negative sign because this is the cost, this is the investment, and you'll have to have a cash outflow in order to start a particular project. So for that particular reason, we have represented this particular value as negative sign. Now you can see, students, in after the first year, project B again will have a particular cash outflow. It means you'll have to again invest $1,000 after the 1 year, and the project B will be able to generate the revenue at the end of the second year, and the revenue generated after the second year will be equal to $2,500. Similarly, the revenue generated by the project B after the third time period or third year, that will be equal to $2,000. So this is about the information given for these projects A and B. The required rate of return or the interest rate in for both of these projects is 10%. Now students, now we are interested in the analysis that which of the projects should be taken by the project manager, whether we should go for the project A or we should go to the project B. And initially, when you see the different amount of the cash inflows and cash outflows, you may not have the idea that which project is most feasible and which project should be taken by the project manager. So for that particular decision, what the financial manager will do, he will have to do the particular financial analysis, and again we can use those concepts like NPV, BCR and IRR, and these concepts will give you the idea that which project is the best project among these two projects available. Now how we can calculate that net present value for the project A? Again, as I told you that for calculating the net present value, what we'll have to do, we'll have to discount all the cash flows. Now discounting means we will have to calculate the present value of all of these cash flows. Now students, you can see for this particular value, this is the present value actually, which is already discounted value, and of course when the time period is 0, there is no need to calculate the present value because it is already the present value, so that value will remain same. Now this particular amount we will get after 1 year, we will have to discount this particular value, and again students will use the same formula, that is present value is equal to future value. Now this is the future value because we are getting this particular revenue after 1 year. So future value divided by 1 plus I raised to the power n, that is 1 plus 0.1, which is the interest rate raised to the power 1. So if we use this particular formula, we will get the discounted value for this particular time period. Similarly, for this particular revenue, we will again use the same formula, that is 1500 divided by 1 plus 0.1 raised to the power 2. Similarly, for this value, 1000 divided by 1 plus 0.1 raised to the power 3. So in this way we will be able to calculate the present value of all of these cash flows. As you can see, now students, this is the present value of $1,000, and again you know about the formula that present value is equal to future value over 1 plus I raised to the power n. Now how we will calculate the value, present value for this $1,000 amount after 1 year. So future value in this particular case is equal to 1000 divided by 1 plus 0.1, 1 plus 0.1 raised to the power n. N in this particular case is 1. So 1000, if we divide 1 by 1.1 to the raised power 1, that particular factor will become 0.9091, and if we calculate this particular value, so it will become the present value of that particular cash flow after the time period of 1, that is the 1 year. Similarly, 1500 are being generated after 2 years. Again, we will use the same formula, that is 1500 divided by 1 plus 0.1 की power 2. Now 2 means because this is being generated after 2 years. Similarly, for this third amount, again we will use the same formula, that is 1000 divided by 1 plus 0.1 raised to the power 3, and again you can get the present value of these amount. 2500 will remain same because this is the cash outflow at present. So there is that is already the present value. So what we have done, we have calculated the present value of the different cash flows, and now if we add up all of these cash flows, the value is equal to 400. Now this 400 is actually the net present value for the project A. Similarly, students, again we can calculate the net present value for the project B in the same manner, that is again 2500 the initial investment, which will remain same because it is the value at present, and again 1000 loss is for the project after 1 year, or there is an initial investment for that particular project, and this loss or that cash outflow is again represented by negative sign. So because this cash outflow is being faced by the project after 1 year, so again we'll have to discount this particular value for 1 year, and again we will use the same formula, that is minus 1000 divided by 1 plus 0.1 raised to the power 1, that is n is equal to 1, and again in this way we can discount this particular value. Similarly, the next amount will be discounted for 2 years, and next amount will be discounted for the 3 years, and if we add up all of these values, we can get the net present value for the project B equal to 160. In this way, students, we can calculate the net present value for the different projects, and now we'll have to decide out that which project is the best project. As you can see that net present value for the project A is greater than the net present value for the project B, and those projects are always preferred whose net present value is greater. Therefore, we will prefer project A because of its net present value. And again, students, those projects are always preferred which have the net present value equal to some positive value. If a particular project have the net present value in negative, then of course we can always reject those projects, or we may also accept the projects with some negative net present value for some social science projects or some non-profitable projects. We can always accept, and we can always accept the projects with some net present value, but for the normal business projects we always prefer the projects whose net present value is positive. And if we have the different alternative projects, and then we will calculate the net present value for all of these projects, and that project will be preferred whose net present value is greater. So the projects with the higher net present values are always better. So this is the way, students, this net present value can help you for the selection of the particular project. Students, there is another very important concept we use in financial analysis of the project, that is a profitability index. Profitability index is also known as benefit cost ratio. And again, the benefit cost ratio is defined as the ratio of the aggregated discounted benefits and aggregated discounted cost. Now, what is the difference between net present value? In the net present value, you can see the formula. What we do, we find out the aggregated discounted benefits and aggregated discounted cost, and then we find out the difference of these two values. But what happens in benefit cost ratio formula, we are going to find out the ratio of these two values. That is, we will find out the ratio of the aggregated discounted benefits and aggregated discounted cost. Aggregated discounted cost means that will be the discounted value of the initial investment or any other cash outflow you may have during the lifetime of the project. So this is the formula for this profitability index. Now again, students, you can see in this formula that this is the ratio of the discounted benefits or discounted revenues to the discounted cost. Again, if we calculate the benefit cost ratio for our projects, that is project A and B for this particular case, again what we'll have to do, first of all, again we'll have to find out the present value of all of the cash flows. That is, we will find out the value of this 2500, which is already the present value, so that will remain unchanged. We will calculate the present value of that $1,000 for 1 year, present value of present value of $1,500 for 2 years, the present value of $1,000 for 3 years. Now what we will do, we will add up this present value at the 1 year, 2nd year and 3rd year, and we will divide this sum by this 2500, which is actually the discounted cost. So students, you can see that this is the present value for the revenue you got after 1 year. This is the present value of the revenue you got after the 2nd year. This is the present value of the revenue you got after the 3rd year. And again, we will add up all of these values and we will divide it by initial investment, that is 2500, ignoring the sign of this particular investment. So by solving all of these values, we can get the benefit cost ratio or profitability index equal to 1.16. Students, whenever the net present value is positive, its benefit cost ratio will be greater than 1. So that is, you can see that when we calculate the net present value of the project A, it was equal to $400, that is a positive value. So the benefit cost ratio will be greater than 1 for this particular project, and that is 1.16. In the same way, we can calculate the benefit cost ratio for our second projects. Again, this is the benefit cost ratio for the project B. Again, for the project B, we have calculated the discounted revenues. You can see that 2500 is the revenue which is being generated after 2 years. This is project B. You can see that 2500 revenue is being generated after 2 years. So what we will do, we will calculate the present value of this amount, present value of this amount, and then we will divide this sum by the present cash outflow and the cash outflow after 1 year, because this is also the cost and we'll also have to discount this particular value for 1 year. So this is the profitability index or the benefit cost ratio for the project B, which is 1.046. Again, you can see that net present value for the project B is positive. So the benefit cost ratio for the project B will also be greater than 1. So this is the interrelationship between net present value and benefit cost ratio. And again, if we compare the benefit cost ratio for the different projects, those projects will be preferred which have the greater benefit cost ratio. Whenever the net present value for a project is 0, the benefit cost ratio will be equal to 1. Now why it is equal to 1? Because in net present value we are finding out the difference of the two values, that is the aggregated discounted benefits and aggregated discounted cost. And in benefit cost ratio the values are same, but the difference is we are calculating the ratio. Now we are dividing those two values. So that's why if net present value is equal to 0, the benefit cost ratio will always be equal to 1. If net present value is positive, the benefit cost ratio will be greater than 1, and if net present value for any project is negative, then the benefit cost ratio or the profitability index for a particular project will be less than 1. Students, after discussing that net present value and benefit cost ratio, the another important concept which is used in financial analysis of the projects, that is the internal rate of return. What is the internal rate of return? It is that interest rate at which your net present value becomes 0, or it is that interest rate at which your benefit cost ratio becomes equal to 1. So this is the discount rate at which the net present value is equal to 0, or benefit cost ratio will become equal to 1, or we can also say that this is the interest rate at which the aggregated discounted benefits will become equal to the aggregated discounted cost. So this is the concept of internal rate of return. And again, we can use this formula in order to calculate the internal rate of return for a project, and this formula, that is the internal rate of return, is equal to LDR, means lower discount rate, plus high discount rate minus low discount rate into net present value of low discount rate divided by net present value of low discount rate minus net present value of high discount rate. Now students, when we will solve the particular example in order to calculate the internal rate of return, I will explain what this formula is about and how we can find out the values of LDR, HDR and net present value of LDR and net present value of HDR, which are being used in this particular formula. There is another concept related to the financial analysis of the projects, that is the payback period. A payback period is that period in which the principal amount of the project or the capital investment of the project is being recovered after the generation of the revenues. If your initial capital investment is being recovered in 2 years, it means the payback period for that particular project will be equal to 2 years. Again, there are two types of payback period. One is the conventional payback period and the other one is the discounted payback period. Now students, again, if we do not take into account the discount rate, or we don't take into account the present value of the different cash flows, then that particular payback period calculated will be the conventional payback period. But if we discount all the cash flows, or we find out the present value of all the cash flows, and then we calculate the payback period, then that payback period will be referred as discounted payback period. So again, this is the conventional payback period, that is the payback period obtained by counting the number of years it takes for cash flow to equal the initial investment. This discounted payback period requires that the cash flow be discounted during the required rate of return before they are added up to the equal the initial investment. So after calculating that conventional payback and discounted payback, you may have the idea that which one should be greater. I will discuss after calculating the payback periods for the different projects. Now suppose students, this is the information for 3 different projects. There are 3 different projects, that is project A, project B, project C, and the lifetime of all of the projects are 5 years, and you can see the different cash outflows and cash inflows for these 3 projects given in this table. Now at present, the project A has the initial capital investment of 2400, so this is the cash outflow, that's why it is represented by this negative sign. The initial capital investment for all of the projects A, B and C is same, that is 2400. Again, this is your investment or cost. You will have to invest this amount, that is 2400, in order to start that particular projects. So these are already the present value of the cost or investment. In first year, project A generates 600, project B generates 800, project C generates 500. Similarly, the amount of revenue to be generated after second, third, fourth and fifth year for the different projects A, B and C are given in this particular table. Now students, how we can calculate the conventional payback period? Let's discuss this conventional payback period. You know, for this project A, the initial investment is 2400. You can see you can get the revenue of 600 in first year, revenue of 600 again in second year. So if we add up these revenues, that is 600 plus 600 1200 plus 600 1800 plus 600 2400. So it means at the end of the fourth year, this sum of the revenue will be equal to the initial investment. So it means its conventional payback period is equal to 4 years, because we define the payback period as it is that time period in which the initial capital investment is recovered through the generation of the revenues. So it means your investment of $2,400 will be recovered after 4 years. So that's why the payback period for this project A is 4 years. Similarly, if you see the revenues for this project B, you can get this initial investment of 2,400 after 3 years, that is 8 plus 8 16 plus 8 24. So initial capital investment will be recovered after 3 years. So it's a conventional payback period will be equal to 3 years. Similarly, students, you can calculate the conventional payback period for project C. So if you add up these values, that is 5 plus 7 12 plus 9 21. So if you add up this particular value, that is 1100, that will be more than 2400. Now how we can calculate the payback period in this particular case? Now students, if we add up these values, you can see that the sum of these three values becomes 2100, and if we add this 1100, it will become greater than 2400. So it gives you the idea that the payback period lies somewhere between third and fourth year. Now how we can calculate the exact value of that payback period? Now you can see that this sum is 2100, but we want to compare it with 2400. The difference is 300. Now what we can do, we can divide this 300 by this particular amount, that is 1100, which is being generated for 1 year. So if we divide this particular amount, it will become equal to approximately 0.3. So it means that in 0.3 years, the total cash inflows will become equal to the total cash outflows, that is 2400. So in this way, we can calculate the value of the conventional payback period, that is 3.3. Now students, again let me explain this particular point in more detail. If you have a sort of confusion, you can see that this particular amount of 1100 is being generated for 1 year. So 1100 is being generated for 1 year, but we want to find out the time period in years in which this amount of 300, which is the difference between 2400 and 2100, is being recovered. So what we can do, we can find out the time period for this amount of 300. So how we can find out? If we use that monetary method, that will become 1 over 1100. For 300, it will become 300 over 1100. So again we will have this value of 0.3. So it means that after 3 years completion, in 0.3 years we may get the revenue of $300, and then it will become equal to total $2400. So that's why the conventional payback period for this particular project is 3.3. Similarly, students, we can also calculate the net present value and the discounted payback period for these projects. Now what we will have to do for the discounted payback periods, students will have to discount all of these values. Yet we have not discounted these values, and without discounting or without finding out the present value of these different cash flows, we have taking into account the different payback periods. But if we first discount all of these values and then we calculate the payback period, then it will be termed as discounted payback period. Now let's discuss the different values, that is the discounted values. As you can see in this particular table, these are the different cash flows for the projects. Now this particular factor is actually equal to 1 over 1 plus 0.1, which is the interest rate, power 1. This particular factor is equal to 1 plus 0.1 power 2. this particular factor is equal to 1 plus 0.1 power 3. Similarly, 1 over 1 plus 0.1 power 4, 1 over 1 plus 0.1 power 5. Now students, after calculating these discounted factors, what we can do, we can multiply this particular factor by this outflow, so you can get the present value of the different cash outflows. So the present value of this 600 for project A is equal to 545.45. Now that is the same formula is being used, that is present value is equal to future value over 1 plus I raised to the power n. So the same formula is being used here. So in this way we can get the present value of all the cash inflows and cash outflows. And again, as you know that we can calculate the net present value by adding the discounted cash inflows and cash outflows. So in this particular column for the project A, you can see that these are the discounted cash flows. This is the discounted cash outflow, that is the investment, and these are the cash inflows, that is the revenues actually. So if we add up these values, so if we add up these values, we will get the net present value for the project A. Similarly, you can get the net present value for the project B, and same way you can get the value of net present value for project C. Now again students, you can always calculate the benefit cost ratio as well. Now how this benefit cost ratio is being calculated? Again, you can sum up all of these values, and again this sum will be divided up by this value, that is 2400, ignoring the negative sign, so it will become equal to 0.95. Similarly, for this project B, what we will do, we will add up all of these discounted cash inflows with that cash outflow, that is 2400, it will become 1.26. In the same way, the benefit cost ratio for the project C will become equal to 1.36. Now again, I told you about the interrelationship between NPV and BCR. You can see that if NPV is negative, the value of BCR is less than 1. When NP is positive, the value of BCR is greater than 1. So that is the interrelationship between NPV and BCR. Now students, again, if you want to calculate the discounted payback period for the different projects, what you will have to do, you will have to sum up these revenues, that in which time period your outflow, that is 2400, will be recovered through the generation of the revenues. We have already calculated the conventional payback period, but in that particular case, what we do, we did not discount the different cash flows. Now if we want to calculate the discounted payback periods, what you will have to do, you will have to take into account these discounted cash flows, and then you will see that after adding up these discounted cash flows, in what time period your investment of 2400 will be recovered. Now class, in this particular case for the project A, if we add up all of these values, then their sum will be equal to 2274. I'm writing here 2274.47. Now you can see that after adding all of these values, their sum will still be less than 2400. So what we can do for the calculation purpose, we can have another cash inflow, that is 600 for the year 6. So it means that your payback period, that is discounted payback period for project A, will be greater than 5 years, and that will be between 5 and 6 years. And again, by using the particular unitary method, we can find out the exact value for the discounted payback period for the project A. Now you can see the difference between 2400 and 2274.47 is equal to 125.57. Now if we calculate the discounted value for this period, that is the 6th period as well, that will become, and the total value will become equal to 338.68. Now this is the discounted value for 6 years. Now why we have counted this 6 year? Because in 5 years the sum of these values was not equal to 2400. Now students, again by using the similar method we used in that conventional payback period, what we can do, we can divide this particular value, that is 125.57, by this cash flow, that is 338.68. so it will become approximately equal to 0.4. It means the discounted payback period for this project A will be equal to 5.4. so that's why, so students, in this way the discounted payback period for the project A is 5.4. Similarly, we can also calculate the discounted payback period for the project B and C. Now students, let's discuss also the internal rate of return. If we are interested to find out the internal rate of return for the project A, suppose, now how we can do that? Now let's see the present value of the project A. You can see that the present value of project A, that is minus 126. Now students, what we'll have to do for calculating that internal rate of return, we'll have to calculate the net present value at the lower interest rate. We have calculated this in net present value at 10% interest rate. Now if we reduce the interest rate, the net present value will be increased. Now the concept is, we want to have the net present value for this project equal to positive at some interest rate. For that particular purpose, we will lower down the interest rate so that we can get the positive net present value. Now suppose we calculate the net present value at the 6%. You can see, now you can see students, these are the different discounted factors at 6% interest rate, and if again if we calculate the present value of the different cash flows and add up all of these cash flows, the net present value at 6% will be equal to 127. Now it is positive because we have lowered down the interest rate. Now students, again this is the particular information we can use for calculating the internal rate of return, that is net present value at 10% was minus 126, net present value at 6%. Now we hypothetically take this interest rate at 6%, it is equal to 127. Now what we will do, we will put this information in this particular formula, low discount rate. Now we have two discount rate, that is 6% and 10% now. Now this 6% is the low discount rate, so we will put 6 here, this one, plus high discount rate is 10%, so 10 minus 6 multiplied by net present value of low discount rate, that is net present value of 6%, it will become 127 divided by net present value of low discount rate, that is 127 minus net present value of high discount rate. Our high discount rate is 10% and its net present value is minus 126. So we will put minus 126 here, and after solving these particular values, we will get the internal rate of return equal to 8%. So students, this is a way you can calculate the internal rate of return for a particular project. But again, please remember that we got the net present value for the project A equal to negative sign. In order to get some positive value or the positive net present value, what we do, we reduce the interest rate so that we can have the positive net present value. अगर ये 6% पे भी पॉजिटिव ना होती स्टूडेंट्स, तो इसको हम फर्दर रिड्यूस कर देते, 5% पे निकाल लेते, 4% पे निकाल लेते, लेकिन आपके पास पॉजिटिव होनी चाहिए नेट प्रेजेंट वैल्यू in order to calculate that internal rate of return. Now suppose again this is the IRR for the project A. If we want to calculate the IRR for the project B, and you can see the net present value at 10% for the project B is positive. Now what we will do, we will not lower down the interest rate, but we will calculate the net present value at the higher interest rate than that 10%. We may calculate at 12% or 13%, 14%, and again we will have this sort of information, that is net present value at low discount rate, net present value of high discount rate, and accordingly we can calculate the internal rate of return for the projects A and B. So students, this is what about the financial analysis of the projects, and we discussed that how we can use the concepts of NPV, BCR, IRR in order to find out the worth of the different projects, and these financial calculations can always guide you that which project should be preferred over the other projects. This is the end of our today's class, and this was our last lecture for this particular topic, that is project management. And of course you will have the practice for all of these approaches we discussed in this particular topic. And again, you should try to solve the similar questions so that you can have the concept of that financial parameters like NPV, BCR, or internal rate of return. Okay students, thank you very much for your patience, and see you next time. Khuda Hafiz. Bismillahirrahmanirrahim. Assalamu alaikum students. I hope you are all fine and must be busy with your work. And in the last two lectures we discussed about a very important topic in operations management, that is the project management. And let's have a brief review, students, what we did in our previous lecture. Students, in the last lecture we discussed a very important topic in project management, that is PERT CPM. And you must know that we discussed some of very important tools which may be